Thank you. Thank you very much. It's very good to be back in England. I used to live here about 15 years ago from 1996 through 2000, and so this is my first visit back since moving back to the USA. How many of y'all have watched the Super Bowl, the American football Super Bowl? Okay. Yes, 40 years in a row, the Americans have won the World Championship of Football. One of the things you might not know about the Super Bowl is in 1968, the New York Jets were trailing by 14 points going into the fourth quarter, and a small child outside the stadium climbed up a telephone pole to see if he could get a better look over the fence, managed to knock loose a plug, and then that was feeding one of the television stations there, so the TV went dark for a minute and a half of the game. During that minute and a half, the Jets scored 3 times and came back to win. One of my favorites, Woody Allen, once said that if you can't be immortal through your work, you can always attain success through catastrophic failure. So that's what we're going to be talking about today. Most of you, I assume, run websites or have access to a website or something, because that's really what I'm focusing on here, and the architecture of websites and how you build them. And I want to give you a little bit of my credentials. I managed to bring down my personal WordPress site multiple times. I have brought down Yahoo Tech while it was covering the launch of the original iPhone, which occurred during the Consumer Electronics Show in Las Vegas. So I was actually in Las Vegas at the time, and I spent about 48 hours straight in my hotel room trying to keep the site up during all of this. And at one point, you know, Steve Jobs gets up, he gives his speech, there's an immense amount of traffic spike there, and I go, maybe if I tweak this, it'll get better. Oh God, no, turn it back. Hurricane Katrina, you should remember that. It was a huge traffic day for Yahoo News I was working on at the time. We typically had an average peak of about 12,000 requests per second. During Hurricane Katrina, we hit about 38,000 requests per second, and it sustained that for a week. During that time, I made the single highest performance improvement in Yahoo News that anyone had ever seen. It was fixing a bug that I had put in there that caused the single largest performance degradation. I fixed the bug, pushed the code out. 5 minutes later, the operations guys go, oh my God, I don't know what you did, but thank you. Because they were readying 600 additional machines to handle the load in our various co-location facilities. Presidential traffic, we managed to sustain 200% above what our expected traffic was during that. And that was a very fascinating thing because we had all sorts of failure scenarios. We watched the traffic creep up and up and up and up, hit those failure scenarios, and actually the site worked better under load than it did at the regular times, mainly because of cache loading and stuff, but we won't get into too much details here. So what I'm going to be talking about here is not just websites. It's really any large system that you have can be caused to fail. And we're going to be discussing some of the ways that you can make things fail and hopefully some of the ways that you can avoid them. A lot of this may be very well known, but unless you've worked on a big site like Yahoo News that sustains these absolutely enormous traffic spikes, it's rare that you see them all put into place simultaneously. So that's some of the stuff we're going to be talking about here. How many of you have ever visited a website and seen this page up here like this? Right? That's a classic, isn't it? What happened? The database connection was down. The database is down. Network connection is down. Who knows? Somehow it can't get the database. You have a database-driven site, and the site, by God, won't work without a database connection. So that's what we're talking about, failure. Anytime the results on the site are not what you expected or what you planned, that's what we call an outage, right? Now, if you plan this right, you may have graceful degradation. You may deliberately serve a more sparsely populated site using less assets, things like that. That's all planned, and that's very good because that means you're handling it the way you want to. When it goes catastrophically wrong is when something happens that you didn't expect and you're totally at a loss for it. The reason things fail is because you're out of something, right? You're out of sockets, you're out of network connections, you're out of memory, you're out of bandwidth, you're out of disk or CPU or something else there. You have a finite amount of all of these resources. And by the way, as I work for a cloud provider, people will tell you the cloud gives you infinite resources. No. Because you have a finite amount of money. And at the very least, there are some criteria that limit you to what you can do. So you need to understand how to handle this. So the question you need to ask yourself if you're running a website is, if my CPU maxes out, what do I do then? If I run out of memory, where do I go? If my bandwidth gets full, and that's hard to do, by the way, but 9/11, I wasn't at Yahoo at the time, but I talked to people who were there, and essentially what happened to Yahoo during 9/11 was that the entire inbound bandwidth of 14 or 15 OC63 lines, several hundred gigabits of data, was totally saturated. So there was no way to serve anything even if they had wanted to. There simply wasn't the bandwidth on the internet available at that time to get it. So they had all sorts of interesting strategies that they put into play to handle that. And let's hope something like that doesn't happen again. A little bit of terminology here. Most of these are TLAs. You know what a TLA is? Three-letter acronym, right? The first one here is an XTLA. You know what that is? That's an extended three-letter acronym. So, SPOF, a single point of failure. What does that mean? It means you've only got one of something. You only have one inbound network connection. You only have one hosting provider. You only have one CPU. That's a single point of failure. Business continuity planning, BCP. How many of y'all have a BCP plan? If you work for a website that drives the revenue for your business, how are you going to keep your business running if your website is down? So that's key there. XSS, cross-site scripting. This doesn't happen anymore, right? I'm all too familiar with that. And a service level agreement. What does a service level agreement mean? It means that someone has promised or guaranteed that they will provide a certain level of service, a certain amount of uptime for you during that time period, right? And that means it'll always happen, right? No, of course, what an SLA means usually is, if I fail to provide you that level of service, then I'll issue a refund for that, right? That doesn't help you if your site is down and you're not getting business out of it. So these are some of the things we're talking about. The first and best way to fail is to be extraordinarily successful, right? You want to serve the biggest, best site. You throw up your site, you're very proud of it, and oh my God, someone mentions it on a talk show on the radio, and suddenly you got a lot more traffic than you expected. You get linked to from Dig or Slashdot or the Oatmeal, or God forbid Yahoo, which drives about 150 times the amount of traffic that those do, right? These are all very good things. It's a very high quality problem, right? What we want to do is keep with the high quality and get rid of the problem part of it, okay? So, move that around. There we go. All those things can cause issues, and the only way to respond to that is redundancy, have more capacity. How do you get that quickly? We're going to talk about that in a little bit later on. Second thing is you trust your hardware. How many of you have you ever run a website on one server? Right? And the disk starts going like a little sound, right? You go out and buy a new server, or you rent another one, or you do something else. Trusting your hardware is a really dangerous thing to do because everything runs on that, and that hardware becomes a single point of failure. So when you plan for failure, you ensure that you have redundancy, or as I like to call it, I'm the redundant department of redundancy department, right? You need to know your limits. You need to test. How many of you know exactly when your website will fail? You need to know that. You actually should be able to bring your own site down, or at least a portion of it, and extrapolate for when you can actually bring the whole thing down. If you're running 10 servers, then ping one of them until you get it to break. 10 times that is your traffic limit, roughly, right? So you need to know what those limits are, and you need to test, and you need to test, and you need to test again. How many of you let random strangers run your business? Right? More of you do than you might think. Anytime you link to something that is stored somewhere else that's not on your site, that really cool JavaScript thing you got from someone, that image library that you're using. In this case, John McCain ran his presidential campaign using WordPress. He used someone's theme that said, "Please do not hotlink my images, I don't want to have to pay for your bandwidth." Guess what John McCain's IT people did? They hotlinked to his images, whereupon the guy who was running that theme site went out and changed them, right? I spent some time on a Yahoo site called Yahoo Shine, which is a women's site. And one of the editors there posted a review of some really fancy high-end blue jeans that were made by a small custom shop in Hollywood. And she linked to a 2.4 megabyte file that was hosted on that little company's servers. That brought down both of us, because neither of us were expecting that. It's really awful to let someone else run your business. I really encourage you to do an audit. Seriously, go through your front-end code, your back-end code. If you have an include or a reference that loads a script or a font file or something somewhere else, you need to understand that even if that's Google, they're now running your business, and an outage for them could mean an outage for you. Or they could screw it up in some other way. The solution for failure is a stable architecture. I always like to emphasize this because a lot of people like to get into the code and see what they can do to make the code run faster or run better. It's not always the code quality. You can even have a high-quality site with poor quality code as long as the architecture is correct. So this is where it gets a little bit dull and boring, and some of you are going to switch off a little bit. That's okay, but if you have questions, ask them. We're going to go through some of the standard architectures and things and talk about this, because one of the things that you find is that getting the right architecture is much easier to build than it is to retrofit in, right? So if you build a properly scaled site with multiple redundancy, it's actually pretty easy to do up front, but it can be very, very difficult to do afterwards. I love using WordPress here. WordPress assumes that all of your image files are stored on the local disk. It is built around the concept of that, which means if you want to scale beyond a certain point and therefore have your images distributed, you need to use something other than WordPress's standard method for image handling, which is to store it on the local disk, right? Replication, you can use a content delivery network, there's a number of plugins. I hammer on WordPress about this a lot because they're very trivial and simplistic, and they do handle the simple cases very well, but they don't actually scale very well. This is where we're trying to get rid of the single point of failure. We're going to talk about scaling. Horizontal scaling versus vertical scaling. Most people don't talk about vertical scaling much. Is that a term that's still in use? 5 or 10 years ago it was common. Vertical scaling means you're going to amp up what you got. Oh, I've got a machine with 1 CPU and 16 gig of RAM. I'm going to bump it up to have 4 CPUs and 64 gig of RAM. So I make it more bigger, bulkier, more powerful, as well as a little bit more redundant. Still in one box, though, still have the problem. Horizontal scaling is much more common, meaning I need my website to run on multiple servers. If I have a web front end, it needs to be stateless so that I can run on 50 of them or 500 of them or 5,000 of them so that we can get out there and do that, right? That's harder to design for up front because everyone likes to use, for example, sessions and just store stuff locally, but suddenly if you're running on multiple servers, that doesn't work. You need to have a different session handler. You need to make those things persistent. You need to do something different, right? So all of those things are methods of scaling, and we're going to talk about both of those. I actually didn't have a reason for this slide. I just found the picture and liked it a lot. It sort of illustrates what I do sometimes. It's not that great. So, Very simple. I run my blog like this, right? It's got a web head and it's got a database server back behind it. In many cases, the database server is actually running on the same machine that you're doing out there. Here's a very, very common system where you have a load balancer, one or two or more web heads out there, and then back into system. Where are the single points of failure in this? Right, you got database, you may have a standby. The load balancer is also a point of failure. Your network coming into that is a potential point of failure. All of those are fairly standard. This is where we start having some fun with it. You can tell I used to be a consultant because we draw lots of boxes with lines and arrows. That's what a consultant does, right? They come in and they draw boxes with lines and arrows. So now we've got redundant load balancers. We've got redundant web servers. We have our database master and database slaves. What's going to bring down this site? Power? Okay. What else? Database master, right? So if you do this right, you can have one of the slaves set up to fail over and be a master or something, but then you've got two of them, so that's very good there, right? This may be adequate for a lot of people, right? If you're not running a mission-critical business, and I've worked, for example, with a lot of city governments, if they're running their systems that let people book appointments with the city manager, well, if that goes down for an hour, no big deal. On the other hand, if you're working with the fire department and the dispatch and the police and stuff, it's kind of critical that that stuff keep running. So that's where you get something a bit more complicated, and you go to multiple redundancies, preferably multi-regional redundancies, right? In this case, you've got duplicates of these. You've got some sort of bidirectional replication between the database masters, or if you don't have lots of updates, you can do database forwarding there. And then very often you'll put both of these in disparate regions, right? Put one of them in the UK, one of them in the US. That way you're going to be insulated against shock there. The tricky part here is the database replication. There's still not a great way to do that, though things are getting better and better all of the time. And these are the sorts of things that you have to work out. Database slaves, you can scale those. At Yahoo, for example, when I was there, we had per region a database master, a failover master, and then a set of child slaves, and each child slaves had about a dozen grandchild slaves so that you could span this out and get as big as you like. We were running about 600 servers per region out there. That's the bulk of this. What I'd like to do, actually, is hear from you, sort of your horror stories. Have any of you brought down a big website? Yeah.
Can I get the microphone to you so that they can hear you in the other room?
Great.
Please?
Yeah, this was actually due to a coding error. We had specific home pages you could set in the CMS. And we built a query so that you could only have one set homepage per site. Only these were 5 of the same site, and the coding error made it so that only one of these 5 sites could have a homepage. So for 10 minutes, the other 4 sites were dead.
So how do you catch that sort of thing, right?
Well, you catch it because the sites are dead.
Well, that's one way. Could you catch it before then?
Yeah, there would probably be some unit tests necessary to catch that.
A unit test, or even a full replicated environment of your production, right?
Yeah.
You run tests against it. The problem with that is it's very expensive to build a fully replicated production environment, right? That's where you need to decide whether it's worthwhile spending the money to build that huge environment. And in some cases, both at Yahoo and other jobs that I've had, it simply wasn't worth the expense. If the site goes down for 5 minutes, it's not that big a deal. You fix it as long as you can fix it rapidly. Anyone else have any horror stories? Yeah. We're going to run the microphone around.
I used to work for a pretty big gaming website, and one of the DevOps rolled out Varnish, and they turned on cookie caching, And so the sessions were cached. There were only 12 sessions in existence. Everybody got one of 12 user accounts. And those poor users, I don't know what they did, but it was a hunting season, basically.
Lovely. That was definitely an oversight. Again, how would you catch that to prevent it from happening?
RTFM.
Yeah, okay. Let me tell another story. I used to work for BMC Software. This is not a web story, but we actually had an IMS database tool that people use to speed up their IMS services. And one day, one of our QA engineers filed a bug against it. And the product author looked at it and said, you know, for this bug to occur, you have to be standing on your left foot and looking this way, and 17 other little conditions have to all fall into place. So it's not going to happen. We're going to just not fix that one because it's far too expensive to fix. 4 years later, we brought down the Vatican Bank. So you have to understand, is it really that rare? And what is the likelihood? He probably actually made the right decision to defer fixing that. Probably not in the eyes of the Vatican Bank, unfortunately, but to others. Who else has a horror story here?
While working on a live sporting event, I was working on an API that updated the scores on the website as it went. I made a little tweak just before the finals to ease it out a little bit. Uploaded the change, and I'd accidentally changed the polling from 60 seconds to 5 seconds with thousands of people hitting the page.
Yes. Polling is a lovely thing to kill sites with. I have to tell another related story here. At Yahoo News or Finance, I don't remember, we were one time brought down by a single person, managed to bring down this massive website. What happened is this person was based in South Africa. They were running over, I think, a 14.4 kbaud modem, right? So they were doing this transatlantic link up to hit the site, and it was so slow that the connections would time out, at which point it would spawn off a new connection. And so we had this one guy over in South Africa on a PC, utterly saturating all of the available Apache connections on the server. It turns out this is actually the name of a certain type of a well-known denial of service attack that you can do with a single computer or very minimal. You don't need a swarm of bots, because by default the Apache threads will time out after something like 24 hours, right? So they'll keep those connections open. And in this case, we had to back the connection timing off to like 2 or 3 seconds, at which point it died automatically. But it was awful to trace back because all you knew is that this one IP address had all these connections open, and until we sort of navigated through the world and figured out where that was, it was tough to find. Any other stories? Yeah, behind you there.
My first professional day at work, my computer hadn't arrived, so they sat me down at this sort of general machine, didn't quite explain what it was, and got me set up. At the end of the day, when I'd finished my work, all of a sudden, as I was about to leave, there were sort of shouts from around the office that the internet had gone down. And I didn't realize it at the time, but they were actually hosting their servers in the office. So not only had everybody else gone down, but the site had gone down as well. We're a compliance information service for the finance industry.
So you were actually running on the live production server?
Well, what they'd done, these are the days before hardware routers and things, there was a Linux box set up as the firewall, essentially managing the connection for the whole office, and because my machine hadn't arrived, that was the one I was on. End of the day, I just switched it off and got my coat.
When I was in university, we ran a VAX 11750 system, and we had these outages that would occur at like 11:30 every night. And it turned out to be the cleaning lady would sort of unplug things so that she could plug in the vacuum cleaner and plug it back in again. I want to talk a little bit about cloud and our architecture. How many of you do prototypes of different architectural configurations with your systems? A lot of times you prototype code, right? You'll write various things and try it and to see what works. We don't tend to think about that with architecture because generally we're used to the days of where we're buying physical hardware, and once we've bought it, we can't really just sort of change it around or something, right? One of the cool things about cloud services, whether it's Rackspace or Amazon or Windows Azure or something, is that you can play with different architecture configurations. Oh, let's spin up 3 different load balancers and try different configurations. Let's try it with 2-level deep application and front-end servers. Because you're only going to run those servers for an hour or 2, and then you can delete them when you're done, and it's only going to cost, 10 or 20 pounds. It's not much at all. And so the cost is no longer there, but yet we tend to think in terms of architecture as something that's static and fixed, when in fact it can be as flexible as anything else we do in the code. Yeah. Are there any questions from the other room?
Questions from room 2? Or confessions, perhaps, from room 2? Oh, okay.
All right. Well, I tell you what, I'll hang around here. This is a little bit faster than most sessions. I sort of came in at the last minute with this, and let's put this up here. If you'd like to try the Rackspace Cloud, developer.rackspace.com, sign up. You'll get either $50 a month for 6 months or £30 a month for 6 months. Give that a try. If you have any more questions, feel free to come up here afterwards. Otherwise, I'll let y'all go early and have 20 minutes or so left.
Are there any more confessions and,
No.
And disasters in the room? No? Well, then, please, let's all thank Glen.
All right.
Thank you very much, Glen, for coming in.
Thank you.
Wonderful talk.